We're back to our regularly unscheduled, semi-scheduled, quasi-scheduled programming. Yeah. Yeah, I don't know. X groups of modules.
Programming.
I don't know. It's hard. Do I really want to? The question is, I sometimes like doing long, messy computations, but do I want to do the long, messy computations that I would need to do to know the X groups of the modules I have in mind? I don't know. I don't know about that. Good morning, Edit Smith. You never did message me what your post was that got removed. Maybe you don't want to reveal. That's fine. But I'm curious, and I remember. Hello, Tobias. Hello. What? Been using a letter for years? That didn't exist? Oh. I mean, if you've been using it, then it technically exists. Turned out to be neither of them, but stylized theta var theta. Seen this the first and last, except in no notes, time used to denote valuation. I know, I bet most probable it is new, yeah. As in used to denote p-adic valuations, yeah. Interesting. Hello, Alakeen. Hello. Or I say it wrong. I don't say it the proper way, right? Aliakin? I always... Aliakin? Yeah, I think it's like that. Aliakin? I could be wrong. I mean, tell me if I'm wrong. I think that's a slightly closer approximation to what it's supposed to be. Yeah, I do use my own. Little notations sometimes. It's going good. It's going good. Thanks for asking. How are you? Yeah. So what math are we gonna get into today? I could always talk about my, if I was trying to go from zero to where I am now, I'd have content for days just talking about my research. But sometimes I'm like, we gotta talk about other things. Gotta get, that's boring. Oh, we could talk about. Do I have an inbox where we can send me stuff? You have a joke paper I might find amusing. Oh, okay. Yeah, my email, ktheorytutoring@gmail.com, should be in the description of most of my videos, unless I forgot to put it there. But it should be in the description of most of my videos. Yeah. I could talk about the research I did in my undergrad. On the connected induced subgraph order. So the mean connected induced subgraph order. So this was started, definitely, this was a concept studied before this paper. But basically what it is you take a graph, so let's say this one, and you ask which graphs have the largest or smallest mean connected induced subgraph order. So what does that mean? Well, so a subgraph is just pick some vertices and some edges. But induced means that you pick edges. If you pick two vertices and there's an edge between them in the parent graph, it must be there in the subgraph. So for instance, this graph would not be induced because I wrote, here's vertex 1, vertex 2. If both of them are going to be in there, then 1 and 2 have to be adjacent to each other. Hey, perverse sheaf question. We know everything is a sum of simple objects. Actually, I don't think that's true. I don't think... is the category of perverse sheaf semi-simple? I'm pretty sure we can have non split extensions actually. But I think there are some Schur's lemma type things because there is some theory. I don't know as much about this, but there's also probably the way to prove it. There's some connection between the modules over the path algebra of a quiver associated to the variety and the category of perverse sheaves. Oh, and affine Grassmannians. Okay. I see. Yeah, I don't know as much about the theory on affine Grassmannians. But I do believe there is something like this. I do believe there are some results to this effect. Yeah, sorry, I can't help you though. Let me know if you figure it out. There is something. Yeah, there's cool stuff. I should be studying the affine Grassmannian. There's like more interesting compatible things that happen when you go over to that world in terms of convolution of sheaves. But yeah. Oh yeah, this is a cool picture. Very cool picture. Always love plotting roots of polynomials. It's always a good time. Yeah. Okay, mean connected induced subgraph order. So that's a now this would be an example of an induced subgraph. And then its order is just the number of vertices. So one way that we can store this information is nice. Well, Langlands is a good thing to be obsessed with. So there's always, if you have other questions about local Langlands type stuff, I can talk about that. But so we can store this information in a generating polynomial where the coefficient will be AK, we will take to be the number of connected induced subgraphs. So I'm defining phi right now. Is this connected subgraph related to zero forcing sets of a graph? I don't remember what a zero forcing set is, so I'm not sure. So always we have a constant term of 1 because we can always choose the empty graph. always the coefficient of x will just be the number of vertices. So for the graph above, it will be 4. Always the coefficient of x squared will be the number of edges, which is also, again, 4 in this example. Now, what are the connected induced subgraphs of order 3? Well, notice that if I demand that this edge be chosen, well, then the thing is, you say, okay, well, maybe I choose this edge and then this edge, but the problem is this would not be induced because I would have to have this edge. So there's no way I could pick those 3 edges and have a connected induced subgraph. So you might try and then choose the edges going this way, but actually that's not going to work either for the exact same reason. And so we see that there's actually only one connected induced subgraph of order 3, and that's to choose this triangle here. So then we get x3. And then finally, your the polynomial has highest degree equal to the number of vertices of the graph, and always that's going to just have coefficient 1, right? Because that's exactly the entire graph. Boris, always coming across with the truest answers. You're thinking about Fourier series of functions periodic with respect to a lattice. Sounds very modular form. Well, periodic with respect to a lattice. Oh, so I guess yeah. I mean, that's definitely more general than modular form. I guess in Rn, right? Like some sort of big generalization to Rn and beyond. So some interesting things about this polynomial. Notice that if you evaluate this polynomial at 1, you will count this will just be equal to the number of connected induced subgraphs. And if you take the derivative of this polynomial and evaluate at 1, well, this will give you the weighted number of connected induced subgraphs. And so therefore, if you're counting the numbers of connected induced subgraphs with multiplicity, then the mean connected induced subgraph order of some graph is just going to be phi prime 1 divided by phi at 1, which is also the derivative of the logarithm of your polynomial evaluated at 1, sometimes called the logarithmic derivative. Yeah, Fourier theory on topological groups. Topological groups, baby. That's where it's at. Not gonna have the 1 in front. Where? Oh, sorry. Yes, you're absolutely right. You're absolutely right. Yes, you're absolutely right. So, yeah. So then there are natural questions you might ask. What are the largest and smallest? Which graphs have the largest and smallest connected induced subgraph order? And so, gosh, wow. It's been like, what, 8 years since I did this? I've reviewed it again since then, so not everything is, completely from just 8 years ago memory. But I believe Jameson started this study, and he proved that among paths of length n, among What a stupid thing to say. Uh, right words, wrong order. For any tree T of order n, the mean connect-induced subgraph order of the path on n vertices is less than or equal to the connect-induced subgraph order of that tree. Do I have a naive geometric interpretation of how sphere spectrum would look like? No, absolutely not. I barely understand anything about it. I half understood something once when I had a conversation with an algebraic topologist at my university. But also, I don't think, I just don't think you're, well, maybe I'm wrong. Maybe there is a way to, monoidal unit in the category of spectra. Yeah, I mean, I don't think, I think it's more of, yeah, I think it's more of a abstract thing. I'm not so sure you should, if you mean algebra geometric interpretation, then Towen often describes it as a fuzzification of spec Z. As for why it's important, that's a huge question. Okay. Suspension, right? You basically you identify it with like a sequence of suspensions, and you take the corresponding homotopy groups, something like that. Explicitly, the nth space in the sphere spectrum, is the n-dimensional structure maps from the suspension. Yeah, it should be some sequence. I wonder what NLab says. NLab might have actually a nice overview. K-theory is the nicest spectra you know. Maybe it's nicer to think of why spectra are useful. Yeah. Right. Spectrum is an object representing a generalized cohomology theory. Aha. I see. Right. Oh, okay. So then it should just be an object like representing the homotopy groups. Devisage, sorry for multiple messages. That's okay, Boris. This is a safe space to get excited about mathematics. There's lots of nice spectra, but the whole point of stable homotopy is to steer away from topology and make it closer to homological algebra. Right. Right. And that's supposed to give us this, right? Smash products spectra. Hulk smash product. Like cohomology turns topology into algebra, but it kind of goes too far. Spectra is somewhere in the middle. Aha. I have heard something like this before. The sphere spectrum is naturally an E infinity ring, and in fact is the initial object in the infinity category of ring spectra. Okay. Right. So I guess this is this explains Towen's line of the fuzzification of spec Z. These just came up the other day, some other document I was looking at. E infinity ring is a commutative monoid in the stable infinity category of spectra. Okay, so it depends on the definition of spectra. Yeah. Where were we here? Back to graphs. So, yeah. We have this result for trees. I should say the result is wide open, actually, in general. The result is wide open in general. I think that one could conjecture that paths are minimal amongst all graphs. I'm not sure, but I don't think there's any counterexamples, known counterexamples to this. Oh, good. That's what I'm here for, to tempt people into Langlands and graph theory. So that's just me corrupting the youth. No, Arcturus. I actually blocked you on Gmail, and I blocked you on Gmail, and I blocked you on Discord because you clearly just aren't taking my advice seriously. So I can't spend any more time. I looked it over, and yeah, it doesn't seem to be that you're taking my advice seriously. So I'll probably block you here now too, cause put user in timeout, hide user on this channel. That's probably what I'll do. So what does this object even do? Which object, Ron, are you asking about? The mean order? No, there was no joke. There was no lead up to a joke. It's just I spent a lot of time talking with this person, and I believed for a long time that maybe they could be pulled back from the from being a crank, because they're, well, allegedly still young, and so maybe there is hope for them, but evidently not. So I can only spend so much time trying to coax someone away from the edge of crankdom. At some point, I've just got to cut it off. Yeah. So, too bad. Yeah. Okay. And so, but I want to talk about the research that I did. So we proved this in a special case. We proved this for the case of block graphs. No way they're actually young. I mean, I don't see any reason to not believe it. I mean, people, whatever. People lie on the internet all the time. You know, I mean, you do see Reddit posts of people being like, I'm 12 years old and I'm reading this book on string theory, and hey, maybe they are. Oh, hello. Say hi to all of Vietnam for me, please, if you could. Nerdy Quagsire. But yeah, this person wasn't doing that. I mean, there's just no, I don't know. There was nothing one way or the other to really indicate this person's age, I would say, other than their claims about what their age are. And I didn't see any reason to. You hate those kids? Hello, Nick. How's it going? Yeah, so the graph polynomial, I mean, it's just sort of, Yeah, I'm not sure to say what the polynomial does, but rather, I mean, the thing we're more interested in, the polynomial is just a certain way to sort of think about holding the data. It gives us an interesting way to write down some formulas for stuff, which I'll show you in a moment. But what we're really interested in is just the mean connected induced subgraph order. So it's just another way to discuss a property of a certain graph, right? It's just another attribute that a graph has, and you can just sort of ask what sort of graphs are extremal with respect to this property, right? So for example, like if you're if you have a large, right, if you're connected induced subgraph order, like it's going to be somewhere between, for any graph, your connected induced subgraph order is going to be somewhere between 1 and n, right? And so if you're closer to 1, then this means roughly that you it means that you have a lot of small connected induced subgraphs. So the majority of your graphs are connected, are small, right? Maybe there's some like bell curve distribution. Actually, that's interesting. I kind of want to write down some formulas, and then because there's a bunch of graphs where you can compute formulas for it. I kind of want to write this down, and then maybe look at the what sort of distributions. I never did that before. So like if we look, the distribution for this one, right? It sort of spikes. It's like very spiked, right? For this graph, it's like there's 2 of these are 4, and then the rest of them are all 1, right? So it's like very just boom, boom, you know. Yeah, it kind of makes me wonder. I'm like, which graph? For example, here's something I have no intuition for. Like which graph has the most peaks and valleys, for instance? This is a question I've never asked or considered. But so, you know, there's usual suspects that you might think about these things, right? So you think extremal graphs. So there's types of graphs that you might want to check out immediately are cycles, paths, stars, complete graphs, just the sort of usual gang. And I mean, anytime you have any sort of concept or structure, you just go and test things out on the usual suspects and see what happens. And so you might think, oh, maybe complete graphs, have a large mean or something. And I don't know. Paths, well, I already told you, conjecturally, paths have the smallest mean connected induced subgraph order. What happened with Arcturus? I'm just tired of talking to people that, I mean, it's obviously not worth my time to try and convince them to not be a crank. It's obviously not working. In undergrad for a CS class, you did an encryption scheme based on the tree path. A number takes to 1 in collats. You converted it into a polynomial in some finite fields and spared in RSA. No idea if it actually works. Did you not get feedback from your prof on whether it works or something? This isn't on OEIS? Well, I don't know how you would put it on OEIS. I don't know, because certainly the means are not going to be integers. So you're not going to get an integer sequence out of this. Yeah. And then also, like, which way do you order the sequence? Yeah. Intuitively, it has to be paths. Yeah, I mean, I agree with you there, right? Simply because, like, the path, right, you're going to have, like what is the polynomial going to look like for the path on n vertices, well, it'll be 1. We'll have n x, right? So we have nx. So that will be the number of n minus 1 x, I should say. No, the number of things of length 1, right, will be nx. You hope my experience with Arcturus does not deter you from all the young people that ask my advice. Well, too late. I've given up. young people, I've given up on you all. I've abandoned hope entirely. And now I'm only going to be doing math for senior citizens. So keep that in mind going forward. You never put it in the event. Man, no feedback whatsoever. Oh. Well, you gotta find some people that can give you some feedback. So then this will be n minus 1. Right, so that's 3 things. And then, right, because there's 1, 2, 3 edges. And then we can see that there'll be 2 connected induced subgraphs of length 2. So n minus 2 x to the 3 plus n Galois in shambles, plus n minus 3 x to the 4. So this will actually just be 1. And so we can actually, it shouldn't be too hard to convince yourself in general that the polynomial of Pn is going to be, well, it'll be 1 plus the sum from k equals 1 up to n of n minus k plus 1 times x times x to the k, right? And I would say, so intuitively, yes, but it's also not so clear that that's going to be the case, right? Because if we look at all the say, terms other than 1 here, I mean, it's kind of got this drop off like this. Like, this is what the distribution looks like. But, and so I guess it goes down to 0 right here. So you're going to have some distribution like this. But, you know, it's you know, it's still maybe not so clear, right? Like you still might want to believe that somehow there's something that like falls off faster, or like there could be one where let's say, okay, there's like maybe one here at the very end, or like a couple at the very end, right? And then, but there's just an absolutely massive peak ahead of time like this or something. So yeah, I mean, we think it's paths, but you know, we know its paths are minimal. Paths are minimal amongst trees. I'll also talk about some results. Well, maybe tomorrow. We're getting towards the end, but Dubov the chess player does look basically the same. Wait, I'm missing some message here. Galois in shambles. Quiche Galois. What? Galois will always be alive. AG, the GOAT, considered him his direct student. Considered himself as his direct student. Interesting. I actually never heard that. Wait, Dubov, are you saying Dubov looks the same as Galois? Very interesting. Dubov bloodline reveal when. All AGers are always glazing AG. Yeah, because it's the greatest. I don't know. What do you want? What do you want, nerdy Quagsire? You'll either be converted or you'll turn to darkness. Those are the two paths. Yeah. So I guess from this we can actually get a formula. We can get a formula for the mean, right? So what is this going to be? It'll be this. over this. So we get what? The sum of k equals 1 up to n. Galois first recorded case of twin death. Oh wait, it's this times k. Over 1 plus this sum. I don't remember my formulas, and this is worked out. This is worked out somewhere in the paper. You're not a real Grothendieck fan if you don't speak French. Ooh, your words hurt only because they're true. Some life advice instead of math. How could one deal with being too naive? I don't know. That's very too naive in what sense? I don't know. Go participate in a whole bunch of horrible, terrible horrors of the world, and let it darken and corrupt your soul. Ask GPT. Yeah. Or I don't know. Try appreciate being naive and appreciate the fact that the world hasn't corrupted you and you haven't seen and done horrible things. I don't know. Those kind of seem like the options, but it's a very broad question, so I don't know. Too naive in what sense? I don't know. Naive about what? Yeah, I don't know. Travel, maybe. I don't know. Could you travel? Go see the world. Maybe that'll make you less naive. I don't know. Yeah, but how can you read Grothendieck's recollections if you don't read them in the original French? You're just gonna read some English translation? Unacceptable. Maybe learn set theory. Yeah. Imagine asking for advice for social relationships in a math chat. Yeah, terrible place to ask for social advice. Actually, some mathematicians are normal people. Wait, what am I saying? That's not true. Being naive is good. Ask Wiles. Wait, what does Wiles have to do with being naive? Model theory if you're truly depraved. Also, on top of that, I'm Canadian. You thought all Canadians knew French? No, it is forced upon us at a young age, but then I rejected it. And I regret it. But yeah, in like grade 4, they make you learn French until grade 4, and then you have a choice, and I chose not to. But I do have hard copies, printed copies of Grothendieck's memoirs in French, which one day I may read. Maybe he meant naive as unsophisticated in math. Maybe, but I thought he said a non-math question. Algebraicists tend to be more single than analysists. So extra bad question. Wow. Is that true? Do analysists get around more? Physicists do. They definitely yeah. They be, what's a PG way to say this? They be dating. That's not the word I'm thinking of. That's not the 7-letter word I'm thinking of. Had a couple of years of French in middle school, and your Abe G-brained future self is so thankful. Yeah. Although it's interesting, I've used, I don't know if I mentioned this yet, but I finally did use some AI in a non-trivial way. For the first time, as in not just checking that it if my students were cheating using AI. And I basically, what I used it for was to translate some French papers, which, to be honest, I could have understood mostly what they were talking about without the AI. But I used Claude to translate a couple of papers for me. It was helpful. Maybe all the algebraicists should just get together. Yeah, big algebraic polycule. How about that? Yes, exactly. I mean, that is how we know that growth and deke was sent from above. The field with one element is fun, after all. This is true, Boris. This is true. There are kids in the chat. Are there? Should there be? Should there be, though? I don't know. Like I said, all my content's for senior citizens now. So I hope everyone in chat is a senior citizen. It has to do with our not being algebraically closed, so they are more open to relationships. I see. Yeah, there's a lot more. Yeah. No, it makes sense. Well, you know what? With that, I think I'm gonna go do some more analysis. I'm gonna do some analysis and see if that improves my dating life. Because my dating life was popping off a lot more when there was arguably more analysis in my life, now that I think about it. So I don't think that's a coincidence. The kids in chat are currently reading that one string theory book. Yeah. Yeah, they're not even paying attention. So, do I be dating? I've devoted my life to math now. So I've stopped doing that, because, math is the one true bay. 10,000 subs, relationship status reveal. 10,000 subs, dating history reveal. Oh, hello, from Nepal. Glad to hear you're a fan. Glad to have you in chat. Although I am about to take off. Dedicate your life to growth and deke? Absolutely not. No. No. To mathematics, yes. Specifically, do some analysis with quant girls. Yes, that's true. Analysis. Doing analysis for quantitative purposes will get you. Yeah. That's how you get babes. That's the plan. The PDE attrition get everything. Okay. Anyways, how do you always arrive when I'm about to take off? I don't know, Fractal Computer. You gotta wake up early. Rise and grind, I guess. Hey, I did a lunch hour one yesterday. Anywho, okay. It's time for us to all go do some analysis and just totally scoop the dating market.